Okay, looking at the continuation of solving for linear systems. Okay, here we have 3 by 5 matrix, and looking for what we have here in solving for the system. And if we take the approach of writing what we have here in terms of echelon form, okay, so I can start out looking at the upper left hand corner, making the -8 into a 1. So I can take what I have in the first row and multiply by -1/8, or divide by -8. So leaving the second and the third rows the same. Okay, have the top row switching over to 1, -2, 3/2, -1, and -3. And now to put this in echelon form, looking at the first column, I have 1, 2, 0. Okay, so we had the desired 1 in the upper left-hand corner, and I want the middle first term, that is the first term from the second row, to also be 0. So I'm going to go from 2 to 0. So I can say that I have everything from the second row and take away 2 times what I have in the first row, since 2 minus 2 is equal to 0. So if I take everything in the second row and deduct twice everything that corresponds from the first row, I'm going to have in the setup, okay, so you have 2 minus 2, -4 minus 2 times -2, both of which will go to 0, and I have 4 minus 2 times 3/2, or 4 minus 3, which is 1, and then we have 2 minus 2 times -1, or 2 plus 2, which is 4, and of course I have -6 minus 2 times -3, which will form additive inverses with -6 plus 6, so this will go to 0. And so we have, here the resulting echelon form. And in the echelon form, so if I look at the leading elements, okay, so I got 1, and then we have in the second row, we got 0, 0, so we have the leading element at 1, and then we have in the last row, okay, you have 1 as the leading element. Okay, and now I'll get into the equations in just a moment. Okay, but for what we have here, just looking for the pivot positions as well as the pivot columns. Okay, so I have, you have pivot where -8 was, and then we have no pivot position from the second column, and we do have from the third column and the fourth column these corresponding portions. Okay, so these will be the pivot positions. And of course, where the pivot positions are, we have the pivot columns. And taking what we have and solving for the system, going on the basis of what we have with echelon form. Okay, so we have with top row, so we have x of 1 minus 2x of 2 plus 3/2 x of 3 minus x of 4 is equal to -3. And then we have from the second row, I have x of 3 plus 4 times x of 4 is equal to 0. And I have that x of 4 is equal to 4. Okay, now anything we have that does not have a leading element, or any column that does not have a leading element, if there is a variable, okay, that's going to become a free variable. Okay, so we got an x of 1 expression, x of 3, x of 4, but there's nothing for x of 2 thanks to the 0 that exists. So we can say that, since we had this 0, that x of 2 is going to be free. Okay, and so we're going to rewrite these equations as much as possible into the fewest possible variables that exist. I'm going to write it exclusively in terms of either a constant or at most a constant and the free variable x of 2. So we have, again, we have x of 2 is free. Again, we have x of 4 is equal to 4. And for x of 3 plus 4 times x of 4 equal to 0, I have that x is equal to -4 times x of 4. And with x of 4 as a constant, x of 3 becomes -4 times 4, which is -16. And for x of 1, okay, so we have, again, So we have x of 1 is equal to negative 3, and then moving the variable terms over, so I have 2 times x of 2 minus 3 halves x of 3 plus x of 4. And with x of 3 and x of 4 as constants, okay, what's going to happen here is that I'm going to have negative 3 plus 2 times x of 2. Again, x of 2 is free. Negative 3 halves times negative 16 is a positive 24. And again, x of 4 was equal to 4. And if I put the constants together, I'm going to come out to 25, and I have plus 2 times x of 2. So we have, in terms of the solution set, we have x of 1 is equal to 25 plus 2 times x of 2. Again, x of 2 is free. And again, we had x of 3 equal to negative 16, and x of 4 equal to 4. Now, this is the development resulting from the echelon form. And had I taken what I had arrived at and put in terms of the reduced echelon form, so we would have, in this particular case, again, so we had our leading elements at 1, 1, and 1. And if I were to make all the other values in their columns, okay, set to 0, so the first leading element, okay, from the first column, everything else is 0. Now we have with the second leading element, okay, so I have 3 halves at the top, 0 at the bottom. So if I make 3 halves as a 0, and so we'll have 3 halves minus 3 halves will go to 0. So I'll be looking at taking the first row and deducting from it, okay, 3 halves times the second row. Okay, so we end up with, in this particular case, I have 1, negative 2, 3 halves minus 3 halves is 0. And then we have negative 1 minus 3 halves times 4, so it'd be like negative 1 minus 6, which would go to negative 7. And I have negative 3. And, okay, so right now, so I got 1 and 1, have zeros exclusively. And now for the remaining leading element, you have this one. And I want to rewrite negative 7 and 4 as zeros. So what I'm going to do here, to go from 4 to 0, I'm going to be taking 4 times the third row. And going from negative 7 to 0, I'm going to add 7 times the third row. And so we have 1, negative 2, 0, 0, 25, 0, 0, 1, 0, negative 16. And again, the last row, we have 0, 0, 0, 1, and 4. And so this is going to be the reduced echelon form. And if I arrived at the solutions, guess what? Now we have like x of 1 minus 2 times x of 2 equal to 25. And again, so I would have x of 1 is equal to 25 plus 2x of 2. And again, x of 2 is free. X of 3 is equal to negative 16. And I have that x of 4 is equal to 4.